Today we're going to talk about acids and bases and their chemical and physical properties and various theories describing them. As an overview, first we will be giving a basic definition of what an acid is and what a base is. Secondly, we'll be comparing a strong acid versus a weak acid, and thirdly, describing three theories of acids and bases. First then, consider a basic definition of an acid and a base. When people hear about acids and bases, images of metal melting liquids and the bottoms of things may come to mind. But in order to understand acids and bases, we will need a proper definition first. Acids are those substances that dissolve in water to form hydrogen ions, whereas bases are those substances that dissolve in water to form hydroxide ions. Acids give protons, whereas bases accept protons. That's a good summary statement. Consider physical and chemical properties of acids. Acids have a pH level less than 7, have a generally sour taste. For example, consider vinegar. Concerning traits of bases, bases have a pH level greater than 7, have an overall bitter taste. For example, if you've ever tried baking soda, you have an idea of what bitter tastes like. If you were to smell an acid, it would burn your nose, like when you drink Coke too fast. However, if you smell a base, it will do nothing. There will be no effect. Turn to the distinction between strong acids and bases and weak acids and bases. A strong acid or base is any substance with a low ionization rate. A weak acid or base is an acid or base with a high ionization rate. Another way of looking at this is to say that a strong acid, for example, has strong molecular bonds, which therefore lead to a low ionization rate with water. A weak acid, conversely, is an acid with weak molecular bonds, which lend themselves to a much higher ionization rate with water. Finally, we will overview three different theories of acids and bases. First, Arrhenius theory, named after chemist Svante Arrhenius. Here, acids and bases can be thought of as ionic compounds composed of cations and anions, naturally enough. When an acid or base dissolves in water, it decomposes into its component cations and anions. An acid is any substance that dissolves in water to form an H+ cation, and a base is any substance that decomposes in water to form an OH- anion. To give an example, hydrochloric acid is an acid because when HCl, or hydrochloric acid, is dissolved in water, it decomposes into hydrogen cations and chlorine anions and is therefore an acid. Secondly, Bronsted-Lowry theory. Here, acids can be thought of as any substance that donates a proton in a reaction, and a base is any substance that accepts a proton in a reaction. Because one proton is a hydrogen atom, we can think of acids as any substance that donate a hydrogen atom in a reaction, and bases any substance that accept a hydrogen atom in a reaction. For example, hydrochloric acid, when added with HOH, produces H3O and chlorine. HCl is the acid and HOH is the base because HCl donates a proton. Here, I have to split it out. Finally, Lewis theory. While Bronsted-Lowry theory defines acids and bases based on the sharing of protons, Lewis theory defines them based on the sharing of electrons. An acid is any substance that receives a pair of electrons in a reaction, and a base is any substance that gives a pair of electrons in a